Good evening, everyone, and welcome to this event. So, today our speakers will be comparing and contrasting different industrial opportunities. In this event, we aim to facilitate the audience to learn about industry research roles and the path leading to these roles. We want to provide the students with some sort of insight into the type of problem statements in machine learning that are dealt with in the industry these days and contrasted with academic research. Today we have our speakers, Samarth Sinha and Jasleen Dhillon, who have good experience having a fair share of their careers in both industry and academia. Samarth is currently a PhD student at the University of Toronto, where he works on 3D reconstruction. Previously, he was an AI resident at the Meta AI Research London. He completed his undergrad in computer engineering at the University of Toronto and was a visiting student at Mila and UC Berkeley. Jasleen is currently a first year master's in computer science student at the University of Texas at Austin. Previously, she was a machine learning consultant at World Quant Predictive. She completed her undergrad in computer science from BITS Pilani and was also an undergraduate researcher at the Laboratory for Computational Social Systems at Triple IT Delhi. We would like to welcome our guests.
For having us here, Amita. Thank you.
Hi, thank you. Yeah, thank you so much for inviting me. Very happy to be here.
Thanks, Samar. Would you like to speak first?
Sure, yeah. I also have some slides. I can kind of share screen if my laptop allows me. Just give me one
Yeah, sure.
second. All right. Can you guys see my screen? Can you guys see my screen?
Yes, Samar, your screen is visible.
Okay, perfect. So just wanted to give a quick set of slides about kind of my journey as a researcher and as like working in industry and academia both. So like it is basically just like I started off from academia, I went to industry for like a year and I also did a lot of industry internships, and now I'm back in academia. And I think my goal of like these set of slides is kind of contextualize and like contrast them with each other. Um, so basically, so a little bit about me. I'm currently, or I did my undergrad at the University of Toronto, and I'm currently doing my PhD at the University of Toronto, first year PhD. But during my undergrad, I was also a visiting student at the University of California, Berkeley, as well as Mila. And those were very interesting and quite similar experiences for me. And also in terms of industry, I did some software engineering slash computer vision engineering internships, both at DeepMap and Aurora, which are both self-driving startups, which was also a very interesting time. I kind of got to like see how self-driving cars work, the problems in the fields. And then I kind of got more involved into research. So I was also a research intern at AWS or Amazon more broadly. And then, I think what might be the most relevant thing for the day is that I was a AI resident at Meta or Facebook in London, which was also a very interesting experience, especially because I got to be there with the team for a full year. And it was a very valuable experience. I learned a lot. I kind of got to switch fields as well in my research, which was a very valuable thing. And then finally, currently, I'm a founding researcher at Luma Labs, where we work on 3D reconstruction, and I'm doing this part-time currently with my PhD. So, I wanted to kind of write down a quick little bit of thoughts that I had contrasting between academia and industry, and kind of like the pros and cons between the two. And so basically, like the academia, like some of the main pros, which I'm very excited about that I'm, a part of it full time now, is that I think you get to enjoy like lots more freedom. People are way more collaborative. Like I was talking to my friend, and she mentioned that as soon as you leave academia or as soon as you leave university, like people are in general like less interested in helping you because, like when you're in academia, everyone is kind of struggling together, right? Like the student experience is very shared between everyone. And you kind of get to like meet some very interesting people and like collaborate with them and talk to them, which I think is like, goes a long way in research. And very flexible hours, and it's getting very easy to make the switch back to industry, which a lot of you might be making sometime soon, or hopefully will be sometime in the future. And in academia, you can also afford to take a lot more risks because there is no real, like, every quarter you're not going to have like a review from your managers. You don't need to have a paper published every quarter, every year even. You can, work on like 2 3 year long-term projects. And, and like those are largely like driven by curiosity, right? Like I'm very interested in topic X and I'm just going to work on topic X for 2 years just because I can. And it's a very open-ended problem solving because like you decide the project, you decide the pace and everything. But some of the bad things about academia is that the pay is pretty bad, especially in comparison to how much you can make in industry for a comparable role. And the hours are very long too. And you have like problems with compute. You are never going to get the similar compute as you will in industry because there's obviously limited resources, a lot more students. Another big problem that I think academia has is that they kind of, deal with very focused problems, and they kind of get out of touch with reality and like what the real problems are. Like you never try to build a product, you never try to solve a need, you try to solve a research problem, which can, which if you're not careful, like you can, work on things which are, I mean, and you might be interested in that, but like there's a tendency for researchers to focus on research problems instead of like problems that are super relevant. And it's very important to have like a good PI/professor, which plays a huge role in like your sanity, really. And that's obviously Joshua Bengio. He was one of my idols in research, and just like how not just smart, but also how ambitious and how driven he is to like proper academic research. And then so a little bit of like some pros and cons about industry research is that some pros is that pay, compute, work life, perks, like it's unmatched. Like especially like if like those research jobs compared, like if you contrast that with academic roles, it is very hard to compare the two. You will have like way better opportunities or way better work-life balance and everything once you work in industry. And some of the nice things are is that you can also work on real products, work close to reality, because like your boss is set the or your manager set like the kind of the agenda for like every quarter or so. um, and you can all like often have like more impactful work. Like if you guys have seen like the recent results in like Imagen and all the OpenAI stuff that they're doing, like those are very high impact stuff, which as a academic researcher, you're really not able to do because you don't have the compute, you don't have all the data, you don't have the engineering infrastructure to have that. So I think industry has like an unmatched level of resources in that sense. And yeah, so like chance to build solutions instead of ideas, because I think academia focuses on ideas and solving like problems as opposed to like creating genuine solutions that people will use. But some of the cons, because everything has cons to it, is that the good team and manager fit is very important for your long-term success. Because like your manager at the end of the day will decide like your promotions, your everything, and so like it's highly it's very important to be very careful with like which team you pick. And it's also far less collaborative and like far less freedom, especially compared to academia. Like I said, in academia, you're in a very unique role where you get to talk to anyone you want, and everyone's interested in helping you. While in academia, or while in industry, it's not as much the case. And there's obviously like the small fish, big large pond thing, where you kind of can get lost in the massiveness of a big company, and there isn't as many open-ended problems that you get to solve. And then finally, there's obviously the golden handcuffs, right? Like you get paid so well, you're treated so well that it gets really hard to leave that life. And but like as good as industry is, as comfortable as it makes your life, like it can leave you a little bit less prone to making risks. So this is a slide that I was kind of working on, but I can go more into it like live instead of just a slide. So like one of the main interview process, which I think might be valuable for a lot of you, would be like how how these interview processes work and like how to kind of like secure such like very 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 demanding roles, or like not very demanding but very competitive roles. And I think like at the end of the day, like if you guys are interested in research or software engineering, either way, like the thing that you can do the best is just be a good software engineer. Be good at like writing good, clean code. And I think like that will, regardless of like the path anyone chooses, it will like this will be the thing that kind of sets you apart from the rest. Like if you're able to good like big infrastructure which can last a long time. So yeah, software is like the main thing, and I think the technical machine learning knowledge, or like say you're a reinforcement learning person, like the core technical knowledge will always be secondary because you will always have to pass the software, the coding tests, the lead code tests. And like I think like, if you really focus on like writing good software, like, crack the CTC books and the lead code test, then it will pay off in the long run. Even though it sounds trivial and it sounds annoying, it is highly valuable because learning how to write good code will always last you a long time. And then finally, like the switch from academia to building products or building industry, as you can see, like a lot of the top researchers have left to join startups or start startups. Like it is easier than it has ever been. And it's a very exciting time that like a lot of the problems that researchers are working on, or academic researchers are working on, it is directly applicable to industry, which makes it quite beautiful to be able to make that switch. And obviously like think about like if any of you or many of you are deciding, like think about what suits you instead of like what is cool, what is everyone else doing. It is very important to like think about what kind of suits your interests, suits your like long-term goals, and what you aspire to do in your long-term career. And I think the number one thing is just like be very careful with the PI, professor, or manager, because it can make or break your experience wherever you go. And like, and I think the end of the day, there's often you can do both industry and academia. Like if you're able to seek the right people, seek the right opportunities, you can often have your leg in both of the ways, which I think is quite beautiful, especially because in computer science, we're in a unique place where we can have like we can make a real impact. We're also doing fundamental science work because the fundamental science work often is so tightly related to making real impact. And yeah, finally, I don't think you guys need to like note this down, but I can leave my contact details elsewhere as well. But that's my email, my Twitter. Feel free to like follow me, message me at any time. I'm always happy to answer questions. But yeah, like that's basically like all the slides that I have, and I'm like happy to answer questions now or whenever.
Thank you, Samarth. I think, yeah, there's a few questions from the audience.
Sure.
So the first question was, how much does your PhD topic really affect the role or project that you'll be working on in like an industry setting?
So I think like a PhD topic, like if you are like when you're doing a PhD, like if you want to like do an internship, or if you want to apply for like a research scientist or a research engineer, or or a software engineering role, it can, like I think after you get your PhD, you can kind of reset what you want to do, because a PhD is kind of like which I'm still learning. It's like you have to like kind of make an impact. You have to have a clear story about like what you want to do. Like it has to like fit into like a narrative of like this is the thing that I'm an expert in, and these are the papers I publish on it. But after you finish your PhD, I think you get a chance to reset your goals. You get a chance to kind of rethink about like what kind of impact you want to make, and what kind of problems you want to work on, and which allows you to like reset. Like if you want to go into like more practical roles, like you can join a startup. If you want to go into like, core like basic science roles, you can always do that. So it is I think after PhD, you have a lot of leeway into what you want to do after. But yeah, like it is tricky that you often have to go away from like your core technical strengths, but that can always be that can be both scary and rewarding in the long run.
Okay, so you also mentioned that sometimes when it comes to academia, you kind of get out of touch with reality with certain problems that academia deals with. Is this in regard to such problems not having much real world application or use cases?
Um, I think that, and also I think a lot of academia becomes about benchmark pushing, and it isn't always clear how like a benchmark, like, if my model performs, some epsilon% better on ImageNet than any other model, right? Like what does that really mean? Like, is my model actually better in like any practical way, right? Like, can I deploy my model better? Will it perform better on my cell phone, where it's often used? Will like, the correlation between like, the many benchmarks that exist in each field, versus what that actually means in terms of like a product or in terms of like a real life, real people use, is quite often unclear, and it is not it is not clear, to at least to me, like what the best way for a researcher to think about like, both things is, without actually like having the opportunity to work in industry directly. But yeah, like I think the problems can also become quite a bit out of touch with like, real world problems. But I think just the benchmark pushing is kind of what I was talking more about.
Right. Okay, so is the point about having less academic freedom in the industry even true for top labs, which work on conceptual and fundamental machine learning or deep learning? For example, DeepMind or Google Brain.
So I've never worked at either Google Brain or DeepMind, but I know a lot of I have a lot of good friends there. And I think every lab is a little bit different. I think Brain allows for a surprising amount of academic freedom, which is, not common. I think DeepMind is still a little bit more focused. Like they have like these big groups working on protein synthesis, with the AlphaFold stuff or like AlphaGo, which was one of the main pushes beforehand. But I think Google Brain kind of like they really focus on like fundamental science research, which I find quite interesting that they're able to. But I think even doing that, they're starting to kind of also deal with products because at the end of the day, Google cares about their profit margins, right? But like at like Facebook, like you're incentivized to like have due to fundamental science research, but it is always better that you are kind of working on like specific topics or specific roles. But like within that role, you're allowed to explore a lot. But like I can't, stop my research like I can in academia and like work 2 months or 2 years on just like computational imaging, right? Like I don't have that kind of freedom in industry like I do in academia.
Right. So, how difficult is it to move from an industry software developer without any hands-on experience in machine learning to, let's say, higher studies, master's or PhD?
Masters, so it kind of depends. I'm not very familiar with the European system, but a lot of the American master's programs are primarily course driven. So I think like those are always relevant. Like they will be costly. They will come at like, a steep hit to your wallet often. But at the end of the day, like the return on investment on those degrees are often very high. Like you will go in debt, but like the type of roles that you will be able to get with those they often outpace not doing the degree. So yeah, so like I definitely think that like the course driven ones, they're like we are all like I think most of you might be undergrad students, and we have done courses, right, like for like the last what 16, 17, 18 years. So and we've gone pretty good at them. So like those master's roles are always interesting, and they're always going to be relevant for any software developer or like any engineer. But I think research takes a little bit of a different thinking. And I think research roles are often also very gatekeepy, which is something I really don't like. But it often turns out that, like, to be able to do high level research, you need to have already done high level research, which is kind of a self-defeating prophecy. But it is kind of a reality because these roles are getting very competitive now. And yeah, so like I think like that transition might be tougher, but if you're able to, like, I think a lot of the people that I've talked to kind of do things on the side, just like have like research projects going or have like collaborations going with like researchers, which kind of like helps bridge the gap a little bit more and like have some publications and stuff.
Right. We have one final question, which is, do you think it's easy to make a switch from an industrial role to academia?
Uh, yes and no. I think it requires a bit of a different mind frame. Like you have to kind of, deal with like different types of problems, different types of people. But it is, or like especially like if you're interested in like research, I think you will always find it fun. Like the core things will be interesting to you, but like it might come at like a cost of like work-life balance. Like the pay is almost always lower in academia, and if you are used to like the high pay, the golden handcuffs, like I said, then it will be tough in that sense. But I think the technical challenges will be similar, if not more interesting, because you kind of get to choose the path that you take. But yeah, so it's definitely possible. Is it hard? Is it uncomfortable? Probably. But is it rewarding? I also think so because I kind of did it. Um, so yeah,
Right. All right. Thank you so much, Samarth, for all of the knowledge.
thank you.
Next, we'll have Jasleen, who will be presenting her slides. Just give me a moment.
Yeah, okay. I think even I can share the screens now. The option is working. Um, so yeah, you can go ahead. It's okay.
All right. Then.
Oh, the option disappeared. Like, it was there when you were sharing.
Yeah, I made you the presenter,
Yeah,
Jasleen.
yeah, it's there. Yeah, okay. Okay, so is it visible? Like my screen?
Yeah.
Okay, so hi everyone. I am Jasleen and I'm currently a master's student here at UT Austin. And I major in computer science and my research is primarily in NLP. And for that, I've pursued both academic internships as well as some industrial experience as well. And today I'm going to be talking about one such industrial experience I had at WorldCon Predictor as a machine learning researcher slash consultant, you can call it. So this role is more on the corporate side and it gives you an insight on how things work in a more industrial setting where you deal with real world data. So yeah, that's what. So my team was basically data scientists from all across the world. We had people from Europe, Australia, US, and we all worked together in a remote setting. And we dealt with client projects that we had. And we all collaborated via whatever internal cloud platform we had. And we were allotted projects from various clients, and then those were modeled as machine learning problems, and we would then deliver required features or predictions. So this is just an overview of what kind of work I had to do there. So this project cycle actually is different from what we usually do in academic um, settings. And so the data that we mostly dealt with was in the finance or healthcare setting. And that is what actually most real world um, situations consist of. So it was, for example, you had companies which would come to us come to us with their healthcare data or with their finance data, and it would be our goal to perform any prediction task that they would ask us, or if the data is too complex to be dealt with, we would then have to perform some sort of feature engineering on it. So it was like, if I sort of explain the pipeline of it, we would get requests from clients, and then they would give us like really huge amounts of data, and it would be largely raw and unstructured. So we would have to like pre-process it a lot. And then we would frame the problem statement, like gauging the expectations of the client and how we can actually employ ML in it, then setting up the model skeleton, and overall, all these projects, they would be very short term, like, deliverable within a month, unlike your academia settings where projects can go on for years. So each client project would probably take a month or so, at max 2 months. So this is like an overview of the projects that we were part of. Yeah, so if I'm to explain a sample project, or like, an example of what kind of projects I did. So healthcare domain is like a really, really flourishing field, you can say, where various ML techniques are being deployed these days. And one of the most common problem is whether hospitals or nursing homes, um, they want this data, like if they have a patient, what's the probability, or like what are the chances that a patient would get readmitted. So for this, like, there would be medical records of the patient. We would have all the data tracked right from the beginning. And then it would be our job to predict using all that data, like what's the probability that patient is returning to the hospital or not. So like this might seem to be a very trivial problem, but the amount of like there are huge stakes involved in this, because this healthcare industry relies a lot on like this readmission process, because you have health insurance involved, you have the healthcare procedures involved. So overall, it might seem like it's just a binary classification task, but the stakes are huge in this problem. So yeah, like if I compare my experience at this in this industrial setting as with other labs that I worked in, there was a lot of freedom to choose the projects that I wanted to do on. Like if I was not interested in a particular client's project, if it wasn't interesting enough, or like the data set wasn't something that I felt like I want to work on, I had the freedom to not work on it. And whatever models we developed, they were all developed collaboratively. Like everyone had their inputs on what kind of model we can build, and like all those models would then be ensembled later on. There was no timing restrictions, like unlike other industries, like we had the freedom of taking as much time as we want to build a model for it. And as part of my experience, I ended up delivering about 7 to 8 projects over a period of almost a year. So another point that I wanted to talk about was how real is real world data. Which have been pre-processed, we have corpuses of data, and like they're all very clean to deal with. But when a client comes to us, the data that they bring is highly unstructured, it's very sparse, and the number of attributes, the number of features to be considered are huge. So it gets quite difficult at the pre-processing stage itself. And since it's real world data, there is a huge amount of bias involved in it. And there's huge imbalance in it. And it is also possible that you don't need to apply high level AI techniques on it. Like it's possible that if you have a text data, you don't need to deploy any language models or anything. Most of the time, your statistical tools are enough for real world data. So, which kind of paves way for another discussion that um, how much like the research being done in academia is different from what is actually deployable in an industrial setting. Talking about the difference from industrial research labs like Google Research, MSR, etc. The data that we had, like it wasn't structured at all. It was like raw from the industry, whatever the clients could collect from various sources. And unless we are using some structured data for models, the data was not structured at all. And there were a lot of projects where your basic machine learning models, like XGBoost, they perform way, way better than any of the complex neural networks that we are having these days. So it's possibility that if you employ any complex neural network like LSTM or anything, it won't give good results at all. It will probably fail miserably. And your basic ML models like random forest or XGBoost would give way better results. Yeah. Another point is there was no research output as deliverable. We were not publishing any results because we just use any of the existing techniques or solutions that are available to us. And that too, like only the computationally feasible ones. So it's not like there is any new research going on. We just use the existing solutions available to us. And the timelines are shorter. We have more freedom on choice of projects, and the required commitment is way less. Yeah. So my takeaway from this experience was that there is a huge, huge gap between AI in a research setting and when it comes to applying that to real world data. As mentioned before, like the data itself is very, very different, and the algorithms, like increasing the size of language models or like setting up higher benchmarks, adding more layers, but none of them actually translates to industrial settings. So there's a huge gap between what is being developed in academia and what is actually useful in industry. And yeah, clients, when they come to us, they have a very surface level idea of what actually AI is. It's more of a buzzword in the industry these days. They just finance companies and healthcare people. They know that there is something known as AI, but they use it at a very high level. And it's a, a buzzword these days. So everybody wants to use it, but they don't know that it's not as easy as it seems. And yeah, as I mentioned before, like advanced techniques like deep neural networks, they fail poorly most of the times. And this is a research direction which I think like people really need to work on how we can reduce the gap between what is being developed in academia and how it's like useful in industry settings with real world data. Yeah, and this is just like another place where like just like you have research labs like Google Research, MSR, DeepMind, workplaces like mostly consultancy companies like BCG or like IBM has IBM Research Labs, or Fractal Analytics is another company which is basically using AI-based tools for its employees, for its clients. So yeah, this is just an overview of other places which perform similar kind of work. So yeah, that would be all from my side. If you have any questions, so yeah, I can answer them.
Thank you, Jasleen. Yeah, so I think we have a couple of questions.
Yeah.
So one of the questions was when it comes to machine learning engineering roles, how much flexibility do you really get in exploring possibly new research ideas or maybe experimenting these ideas on your own?
I think that depends a lot on your workplace. But if you're talking about job firms like, let's say, WorldQuant or any BCG, as I mentioned, you won't publish or research anything new. You are more focused on delivering solutions using the existing techniques. So the scope of working on anything new or is very less as compared to research labs like Microsoft, where your focus is simply on generating new results or publishing new work. So as an engineer, you're more focused on the software part as well and how you can deploy existing models to current setting.
Right. So kind of similar to that question. So what is the scope of research in, let's say, upcoming startups in AI, maybe even healthcare?
I think scope of research would mostly be um, how well can existing solutions perform? Like even if we have neural networks, so since they don't perform that well, so I think like working on existing solutions as well, and improving their accuracy instead of finding newer and newer models. Whatever we have currently, it's important that we focus on them and improve their performance on data. So I think that's one step which we need to take before we go on and develop newer models.
So in your work situations, do you encounter specific situations where you're stuck on a particular problem for a long time? And is this like a recurring problem? What's the next step from there then?
Yeah, so since I think one of the most common issues is the type of attributes the data has, it is possible that none of the attributes are actually useful. Like we're given huge amount of columns, let's say you have hundreds of columns, but none of them are actually giving you good results. So I think choosing the important features of data, that's I think the most crucial step where we get stuck because we have to find out what feature is actually useful in it. Because as I mentioned, like data is very unstructured. So feature engineering is what we have to use very frequently to extract the important features. That's, I think, a really crucial step.
Are there any more questions? I think there were a couple of questions which were left over from last time for Samarth. Samarth, he's still here.
So here, yeah.
Yeah. So the question was, currently I'm doing a PhD in neuroscience. I want to pivot to the tech industry to further my career. What strategy would be good for me for this transition?
Uh, so that's a good question. I am not an expert in neurosci, but I know that like a lot of the computational bio or comp neuro people have made that successful transition. I think like one of my good friends, well, not a good friend, like was someone I know. He did a degree in proper cognitive science where like it wasn't about coding, it was about like pen and paper math. And like he like worked a lot on like PGMs and stuff. um and he's now at DM, working on like with like the cog side people there. And like there's also like some labs at AWS in Germany at Tübingen, which also are like interested in like pen and paper, like causal models and stuff. So it kind of depends on like the type of research you do. If like you're like if it's like comp neural type style of research where like you're strong with software, I think it's always easy to make that transition, especially if you have like if like the key insights from like neuroscience. Those can always be quite valuable, especially because like deep learning broadly is trying to mimic the way brain works. There's a hot debate about like if it's getting there or not, or if that's the correct way to look at it. But like those insights are always useful, but there are probably some skills that would need to be sharpened, such as like software, like the core deep learning, machine learning knowledge. But there are always opportunities in these like big research labs or like other places where you can find interesting roles for like those type of backgrounds.
Right. And there was one more question about when you're in academia, how much of the research is really motivated uh, with the goal of turning the research into a product?
None. I don't think there's any incentive unless you define it yourself. Like I know a lot of my friends who are interested in like building their startup and like or like basically using a PhD as like a runway to build their startup, which is a very ambitious thing. And I think academia allows you to do that. Even when you're even when you're in like a PhD program, master's program, you like the university only bites off the top a little bit. They give you the resources to build it, like you can use like the resources, the infra at the university while working on your own thing. But at the end of the day, the average researcher doesn't need to think about a product or any kind of end, like the end game. They just do their research kind of like in their own shell. But if you're ambitious, if you're interested in wanting to do a startup, thinking about a product, then there's more than enough resources in academia to kind of like help you transition to industry.
Right. I think this question is for both of you. So how competitive are machine learning or artificial intelligence jobs, particularly in our current market?
Yeah, feel free to go ahead, Jasleen.
Yeah, so as a master's student, I think it's more difficult because having a PhD really helps you because at least for roles at, let's say, Google Research or Meta, like there are quite a few positions for PhD people, but for masters, I think they require more research. Their expectations are a lot more. And you have like research engineer roles for master's student, but for PhD, you have like, let's say, research scientist roles. So I'd say like if your focus is to strictly get into ML, so like a PhD is something that you might consider because masters like sort of restricts you to a certain level of roles, and it's more on the software engineering side as compared to PhD.
Right. Again, a question to both of you. Oh, wait, sorry. I think I didn't let someone speak, right?
Oh, I broadly agree. I think um I mean I don't think like those are the only roles out there. Like there are lots of very interesting stuff you can do and build with like the machine learning AI technology, like in terms of like a software role like in a startup, which often give you more interesting technical challenges because deep learning works pretty well in even to scale. But to scale, to scale it up for a specific task is still a very open problem. And that's kind of where you can do very interesting stuff. It's not going to be core science. You're not going to be working on MNIST, lifelong learning, right? Like you're going to be working with real data, which Jasleen was talking about, which can be very challenging. And those type of roles are still competitive, but they can be both competitive and very valuable. Um, and I think a lot of these big tech companies have sort of like hiring freezes, which isn't which is definitely true. Which makes startups more valuable, right? And there are more opportunities there, more freedom, more chances to grow. So yeah, like if you guys are interested in like startups and building or joining like smaller companies, not just the big ones, then I think it's a very, very good time to do that.
Again, this question is aimed from both of you all, I guess. So, what are some particular subfields of AI that are finding a lot of applications in the industry these days?
So I think NLP is like one of the most hotshot field these days. Like a lot of companies and are focusing in this language models field. Um, so yeah, I think like as you move towards like let's say RL, like the number of opportunities sort of start to reduce because again, they're from application point of view, like it's difficult to implement them. But according to me, I think NLP is one such field which is like really flourishing these days. Apart from obviously like basic your machine learning and deep learning, basic stuff like that.
Yeah, that's true. I think like language is very hot right now because OpenAI or like these like large language models have really changed the game. Um, but uh, but yeah, I think some of these startups are a little bit misguided, but I think that's a totally different topic. But I mean, yeah, like large language models, NLP, I think 3D vision is having its own resurgence into the spotlight, which I find quite exciting because that's what I work on. I think like images used to be a thing back in like 2010s, and I think 2020s is a lot more about like video processing because the hardware has really caught up to deal with like these temporal correlations, which is also very exciting. But yeah, like I think machine learning will always, or like scaling up machine learning will always be like a really cool challenge, which will likely outlive us as a whole.
So one more question, which I think I'm curious about myself. How intertwined are the roles of an ML engineer and a data scientist? And can you get these both of the type of roles using, let's say, a master's in computer science, or does it require some specific skill set for each of them?
Yeah, do you want to go ahead? I'm not an expert in this topic.
Yeah, so there is quite a bit of overlap, but data science is less computer science than ML, I think. Like data science is also about databases. It also involves MySQL and dealing with the analysis part more than the, you can say, the computer science part. You have to deal with like, as I said, databases, and it's more about observing patterns, more stats, more maths as compared to machine learning. Machine learning is more on the algorithmic side and more, it can be more researchy as compared to data science. So even though there is overlap, there is like some kind of significant difference also.
Right. I think some of this question is specifically for you. Why did you decide to go back to doing a PhD after getting into an industrial role?
Uh, I so like one of the I always wanted to get a PhD. Like even after I finished my undergrad, I was very interested in PhD. But I also like in that process, I kind of wanted to also switch topics because I like my undergrad research was mostly about like the core machine learning, core deep learning questions, or like and like very like what I meant by like researchers working in like on like research problems, and I was very interested in that because it was it was easy, or it was easier. I wouldn't say it was easy because it wasn't. Um, but like and then I wanted to switch like 3D reconstruction, work with like real data, work with like like Facebook kind of data, and like the role helped me switch over to the new topic, which was one of the main reasons I took it. And then yeah, so coming back was a very easy decision for me because I was very interested in research. And I like like I mentioned before, I am very much interested in doing a startup, and I look at a PhD as like it is basically a startup, right? Like you have to kind of build a story, build a in the startup language, build a pitch deck to be able to like pitch your idea, pitch it to whoever your examiners are going to be. So it is like basically like a preview of like what I want to do in like my later years anyway. So I think it's a good time to do a PhD, and I think especially with the market not doing so hot right now, it's not a bad idea to go back to school. So yeah.
Okay, so there's one more question. So would you guys recommend young graduates to explore roles or problems in the industry before committing themselves to pursue a PhD?
I highly recommend it. I think as you guys might be able to tell already, but I'm very big on like writing or like being a good software engineer. Like I think that is the core thing to learn for any role, whether it's like again a software engineer or as a researcher. Like if you're able to build good good scalable infrastructure, then it will always make your research role much easier. So I say yes, but I don't think it's required. I think you can do really good research without being an excellent software engineer. But I do think that it is something that will still help. And I think having that kind of experience building, working with like a big team on a big project can always pay dividends later on in your research career.
Jasleen, do you have any take on this?
Yeah, I think for PhD, like there's no harm in like exploring whatever you want to do, because I feel like it's also important when it comes to PhD to decide the topic. I think that becomes a very important thing because you have to actually work on it for the next 4 or 5 years. So it's important that you explore all the fields. At least that's what I did in my undergrad before deciding that, okay, I want to do a master's and I'll be streamlining my field to NLP. And before that, I explored all the various fields like adversarial learning, RL, and all. So yes, I think for PhD, one might consider.
Samarth, there's a question for you, which was about can you please shed some more light about your experience as an AI resident at Meta?
Yeah, it was so basically like the way AI residency works is that you kind of work with your team on like you kind of get to choose if you want to work on like well, okay, no, you usually work on like this like one big project. And I was working with like Fair Excel or Fair in London, which was with like and the team worked on like 3D reconstruction broadly. And my paper, which should be out very soon, was on that topic. We was extending a previous paper that like the team worked on, and it was a very nice experience because like the amount of resources that I had, the amount of um, like the other things I have, I can't share too much unfortunately, but the other resources I had or in the experts that I could talk to within the team was very valuable. It like made the transition process very easy or much easier than I would have if I were to just like try to learn everything by myself. Um, but yeah, so AI residents, you get to do like core science research, while also being focused on like writing good code, writing good documentation, and like doing like good practices, which I have like realized now that it is something that I would like to do my PhD as well, because like it takes like 20% more time, but when you revisit your code 20 months down the road, which you might have to, it will be readable, it will be understandable, which I can't say I was good at before I was at Facebook or before I was at Amazon. So yeah, residency, very interesting job. Like you get to work on core science, you get to like write papers. Like that is the goal of the residency. And yeah, like if anyone has any more questions about the residency, like I'm happy to answer them offline as well.
I think this question is for both of you all. So, can you give a good roadmap to pursue machine learning as a career and possibly get into very good companies as an undergrad in computer science?
Uh, I think like a lot of these companies are about like contacts because the volume of applications they get is just like insane, right? Like even though they have like dedicated recruiters, they have dedicated people on these roles, like it's just impossible to like give every application like the full time that it would deserve. Uh, so I think just like if you have contacts, if you know like a recruiter, if you just like don't just worry about like applying, just like DM every recruiter that you can find on LinkedIn, just like be very like shameless about just like writing emails and just like writing follow-ups, right? Like given a reasonable amount of time. I think like that is one of the things that I've learned the best is like at the end of the day, like if they don't respond, they will not remember you, right? Like you have nothing to lose by just like spamming someone's emails. So yeah, I think like contacts, I think is one of the biggest things when you're looking for like industry roles or academic roles. And even after undergrads, I think people can get very good roles if they have like good experiences, if they have like built things on their side project, or if they have like written papers. They can always like get very cool roles in big companies or in like small companies that are going to be big. But like it is very possible to like land these roles after undergrad, which is which is a very exciting thing, right? Because like this doesn't exist in most other fields.
Yeah, I actually agree with the networking part. Connections do actually matter. Um, yeah. So especially with the kind of machine learning market we have these days, like there are a lot of people. Just like I think my internet is lagging. Yeah. So yeah, given the machine learning market that we have these days, there are like just too many people in this field. So having connections, especially with your professors, with your advisors, because these people usually tend to have industry connections as well. So that really helps. And as far as starting in ML is concerned, I think you can take up the relevant coursework in your undergrad and start working on projects with professors, and think that would be a good start. There are a lot of resources available. Um, Please do not get confused and just stick to one thing and follow that, and make it that really helps.
I think your voice cut out a little towards the end.
Yeah, so as I was saying, there are a lot of resources available online. So the key is not to be confused with them. Just stick to a plan, follow one resource which you find, and work with professors and find connections.
All right. I think that's it for the questions. Thank you guys so much for coming. Thank you, Summer. Thank you, Jasleen.
Yeah, no
Um,
problem.
yeah. So I think the next event will start at around 10 p.m. and it would be poster presentation as well as a talk about adjusting to life in Germany.